being here. I feel very happy to learn that so many of you are interested. And also, of course, thanks to NSERC for making these series possible and also for making our research possible. So there. So as Audrey mentioned, the talk that I will be giving today is titled Designing Physical Interactions. And the plan that I have is to sort of mostly show you a breadth of things that I do. And I won't get into the details of all the projects as there's mostly a accompanying paper for most of the projects that I'm showing that I can pass on to you if you're looking for more details, but also happy to sort of discuss them during the Q&A period. So I want to kind of use this as an opportunity to almost do a little bit of a show and tell of sorts, where I show you a bunch of video reels and images and sort of give you a high level overview of what I do and what my students actually do. And hopefully that works, and then we can chat about anything that piques your interest. So just a little bit about me. As Audrey did mention, I am currently an assistant professor at the University of Victoria in the Department of Computer Science. And previously, I was an assistant professor at OCAD, which is in Toronto, for 2 years. And before that, I completed my PhD from the University of Calgary in 2017. In terms of research, and also just generally things that I personally enjoy. I really enjoy playing with machines that make things, so 3D printers or knitting machines. These are things I really enjoy. I also enjoy building tools to support hands-on activities. I like conducting studies to learn more about people in terms of how they respond to technology or how they use technology. And over the years, I've come to learn that I actually also enjoy writing about all of these things. So it works pretty well for me in terms of the work that I've chosen to do. Beyond the sort of personal interest in the things that I enjoy doing, there are other reasons for also why I do research in the area of physical and tangible interactions. One is this sort of idea that really we exist in a physical world, we are physical beings, we communicate, and we also sort of interact with things around us through some sort of physical medium, at least in most cases, or tangible medium. And because there is absolutely no escaping this physical world anytime soon, I'm really interested in sort of thinking about how to make it more user-friendly, usable, and fun for the diverse people and populations who occupy this world. Also, I'm highly inspired by the research in ubiquitous computing and tangible user interfaces that I personally believe have sort of really paved the way to show us that we can really sort of leverage the interplay between digital technologies and the physicality of humans in the world around us. And using those, we can sort of create alternate forms of interactions or new forms of interactions. And these sort of visions of research in ubiquitous computing and tangible user interfaces, along with now the many technologies that are becoming available, say like AR, VR, or fabrication devices, really sort of lets us answer some application related questions. So we can take some of those visions and sort of apply them to daily applications and understand how it might impact people's everyday lives. So for example, we're able to sort of in today's world answer questions like, can we transform physical spaces dynamically? And this can be for all sorts of reasons, so say to make it more inclusive, or to say address some of the real issues in the world where we have smaller spaces as the cities get more populated. So can we sort of make these spaces more dynamically changing and shifting? Or we can answer questions like, can children who don't have access to good quality education learn by creating things and do so using what is readily available? So can we use our smartphones, or can we use low-cost VR as a way to sort of help these children learn? So these are the questions that I personally enjoy thinking about, but also they're possible to address now. And these are things that I'm thinking about. So sort of inspired by all of these reasons that I kind of just briefly highlighted, in my group, the Creative Experiences Lab, we do research in topics related to human-computer interaction, physical and tangible user interfaces, tools for making human-robotic interaction to some extent, and accessibility more recently. And of course, all of this work is really only possible thanks to these awesome folks who I get to work with, some whose pictures are not on the slide because they're camera shy, but their contribution is just as important. So I owe a big gratitude to these folks and to my collaborators for making a lot of this work possible. So in today's talk, I want to briefly show you projects that sort of cluster around 3 recent questions that we are thinking about in the group. One is, how might emerging physical technologies communicate with us and each other as part of our everyday activities? The second question is, once we sort of start to learn a little bit about how we can communicate and how technologies communicate with us, I'm also interested in thinking about how do we sort of transition into and out of these experiences with physical technologies. And then sort of going into a more, the application side of things or empowerment side of things, I'm interested in thinking about what do people do with these technologies? So beyond sort of being passive users of these technologies, what can they do? So I'm particularly interested in thinking about how would people create things by themselves using these technologies, and why would they create them, and what do these objects mean to these people? So these are some of the high-level questions we're thinking about in the group, and today I'll show you a few projects that sort of fit under these clusters. Like I mentioned previously, I'll sort of mostly just show you videos and pictures, but I'm happy to discuss details of anything that you're interested in. Okay. So to begin, we'll start with this question on how might emerging physical devices communicate with us and each other in the context of recurring everyday activities. And the project that I want to show you first is this project on autonomous vehicles and rethinking or thinking maybe, how would we cross the street in the presence of autonomous vehicles? And there's a range in autonomous vehicles. So there is manually driven vehicles, and there are semi-autonomous vehicles, which we actually already see in our streets. And then there are those where there may be a driver, but still they don't really have to pay much attention. And then they're fully autonomous, where the idea is that there won't be a driver in these vehicles, and these vehicles can sort of drive around by themselves. So how would these technologies communicate with us in order to ensure that we make safe crossing decisions? So the current state is that usually when you're trying to cross a street, you get signals from the environment. So you get a cross signal that tells you can cross the street, or you can see the vehicle sort of slowing down at a crosswalk, so you know that it's most likely okay to cross, or the driver will make eye contact with you or sort of wave you saying, okay, you can cross. And you sort of take all of these considerations, and then you think, okay, I think it's okay to cross the street now. And of course, this crossing decision becomes more complex depending on where you're trying to cross the street. So if you were trying to cross this busy street in my home city, which is Bangalore in India, it can get more complex than, say, if you were crossing the street in Victoria, where I'm right now. So we're thinking about what happens to this already somewhat complex process if we throw into the mix AVs, and also what happens where if some of the vehicles have drivers, some of the vehicles don't have any driver. How do pedestrians sort of build trust, or how do they sort of make safe crossing decisions, and how do these vehicles communicate with us? So in this project in particular, we were looking at how can we design explicit interfaces that can go on either the vehicle, or it can become part of the street or the vehicle infrastructure, or it can be on the pedestrian themselves, or it can be a mix of all of these. So if there's something on the vehicle, there's something in the street, or there's something on the person. And how can these explicit interfaces communicate with us? And we also wanted to do a study to know if these would be meaningful. Like, do people need these interfaces, or is the physicality of the vehicle, that is its speed, is that enough for people? So I want to show you a video, and hopefully it will work. I hope the audio is working, but if it's not, just please let me know, and then I can talk over it. And I will also explain it after the video plays.
Autonomous vehicles are just around the corner. When they are introduced to our streets, they will share the road with driver-driven vehicles as well as semi-autonomous vehicles in mixed traffic conditions. Crossing the street as a pedestrian can be a difficult task. With mixed traffic, pedestrians are likely to have a harder time crossing the street. Some vehicles will have drivers to provide cues, while autonomous vehicles will not provide any cues other than through their motion. To examine how autonomous vehicles can communicate with pedestrians in mixed traffic, we built a pedestrian simulator in virtual reality. We immerse participants in a virtual street environment where they observe mixed traffic. In our study, participants assessed their comfort in crossing and signaled their crossing decision using a remote. In our study, we varied factors such as the autonomy level of vehicles on the street and group pedestrian behavior. We prototyped different interfaces to allow autonomous vehicles to communicate with pedestrians in mixed traffic. For example, we used visual cues, auditory cues,
I see you, cross,
and physical cues. We found that VR pedestrian simulators can be a useful tool to examine mixed traffic pedestrian interaction, and we suggest design considerations for building interfaces for autonomous vehicles in mixed traffic.
So just to sort of quickly recap, this is Karthik's video where he's talking about the simulator that we built, where we could play with a lot of variables, such as how many vehicles are on the street, what would their autonomy be. So in this particular frame, you see this, there is a driver in one of the vehicles, but they're distracted, and there's one vehicle which has no driver. And then we could also put manually driven vehicles where the driver is actually paying full attention. And we could also put a number of interfaces on these vehicles. So we could put, say, like an LED strip, or we could put like an actual tangible artifact on the vehicle, like a waving hand, or we could have audio signals that are sort of coming out of the vehicle, and they communicate with the pedestrian, or they can sort of buzz on a phone that the person has. So the idea was that we were able to conduct a study by sort of having people immersed in this environment, and then they could tell us how comfortable they would feel about making a crossing decision, and also if they would actually cross if this was the scenario. And we did a number of studies. So we did some in person as well. We had a Segway sort of crossing a corridor, and people were trying to decide if they would cross. And the Segway we could actually control autonomously, so it could go by itself without a person on board. We did some in-person studies as well, where we kind of pretended that the car was autonomous, but we were sort of sitting inside and controlling it, and we collected data from those studies. We've done some simulator studies with cyclists, and more recently some work on people who use wheelchairs, and sort of looking at how do they sort of respond to AVs and them communicating with us. So some high-level lessons that we've learned is that one thing that we've seen sort of consistently repeating across many of these studies is that all our participants say that having these explicit interfaces communicate with them is particularly helpful, and especially so in the sort of mixed traffic situation where some have drivers, some don't. And of course, we don't know if this is like a long-term requirement, but at least it seems like initially that's what would be required in order to be able to build some trust, and also to be able to make safe crossing decisions. The other sort of interesting part that's come out of these studies is that right now, most of the sort of communication from vehicles either happens through the vehicle itself or the driver, or it happens as part of street infrastructure. So there's like a signal that tells us you can cross now. But one thing that we sort of learned from some of these studies is that now these communications can be made much more individualized, and these interfaces can exist on the pedestrian themselves. And this is because these vehicles will have the ability to sort of communicate via these signals directly to the person. And we are able to maybe even think of collective information sort of being communicated to individuals. So in that sort of building on that idea is some work that we've just started, and this is from Sabrina, who is doing this as part of her undergraduate honors thesis work at Calgary, and looking at wearables and looking at how wearables can be used as a means of communication between pedestrians and autonomous vehicles. So these are some ideas that Sabrina has sketched, looking at maybe, say, having memory alloys in shirts or sweaters, and they sort of either constrict a little bit or they become loose as you feel, as it sort of wants to communicate that it's safe to cross or it's not safe to cross. Or it can be a scarf that sort of becomes a bit more free-flowing when it's safe, or it sort of hugs you a little bit closer when it's not safe. So she's thinking about these kinds of ideas. We're sort of an initial stage of brainstorming ideas, and we're looking forward to know what we will learn from these studies going forward. So that's an example of a project looking at how physical technologies can communicate with us. So at this point, I sort of want to transition to the second question of how do we support transitions into and out of technological experiences? So say we keep learning a little bit more about how these technologies communicate with us and how we might communicate with them as part of our everyday activities. An interesting sort of related question is, how do we actually get into these experiences and how do we get out of these experiences? So as a simple sort of thought exercise, like try to imagine a time where you went to, say, a theme park like Universal Studios or something similar, and you were sort of getting ready to go on a ride. And as part of that, there's a certain routine. You're sort of standing in the line where you're mentally preparing for a very thrill-seeking ride, for example. And when you get on the ride, they will sort of put seat belts, or they'll have the seat sort of go over your head, and there's a security thing. And then you mentally prepare yourself once the ride starts, and then you sort of enjoy the ride. And when you come back, depending on what the ride was, I don't know if you were sort of like hanging upside down in some of those rides, when you come back, you sort of come down and you take the belts off and you sort of walk, and then you sort of breathe. So there are these routines that we already do in order to sort of transition into and out of physical technological experiences. This is also true for, say, if you drive a car or you drive other vehicles, where we wear our seat belt, we are more aware of the environment when we're driving, and then we come out of it, we sort of take out a seat belt, we lock the car, and these sort of help us prepare to get into the mindsets of these different kinds of roles that we play. So we were thinking about similar kinds of things, and we were thinking about how would we be able to support these transitions into and out of technological experiences. And at the time, we were inspired by this project that VR, and this paper that was called Dream is Collapsing, and sort of looking at how people transition into and out of VR experiences. So we were inspired by that and wanted to see how people would do it in physical augmented experiences. So this is a project that Noor led, and this was actually part of her undergraduate honors thesis work as well. And Noor was thinking about how this would happen, say, with people who might be wearing wearable limbs, so sort of becoming like a cyborg or have like an exoskeleton that they might be wearing in, say, like a factory environment. Those were sort of the use cases we were imagining. But in order to understand how we would sort of transition or help people transition into and out of these experiences, we kind of wanted to do something smaller and simpler and first try to get a hang of some of the basics. And so we collaborated with all these folks who are listed on this slide, but in particular, Patrick Finn, who has a background in performance arts. And he was telling us about how actors do this as part of their daily job. They sort of transition into and out of characters and into and out of props that they wear, and how they already have these sort of protocols or routines in place, which are called warm up and cool down protocols, that lets them sort of physically and mentally sort of transition into and out of these different states. So the idea was to take those warm up and cool down protocols and sort of apply them in the context of wearable limbs or cyborg experiences and see how people would respond to that. And as a starting point, we worked with 2 actors who knew the protocol, and we wanted to see how they would adapt those and what they think about adapting those if the performance was now with, say, with technological props like a wearable limb that could be controlled automatically or explicitly or implicitly by them. So let me show you a video of how this works. And again, if the audio doesn't work, please do let me know.
Be or not to be? That is the question.
To die, to sleep no more.
The law's delay, the insolence of office, and the spurns at patient merit of the unworthy takes, when he himself might his quietus make with a bare bodkin.
So I'll stop the video here and sort of just quickly recap what was happening. So like I mentioned, they were going to sort of see how it would feel to sort of perform with these wearable limbs. And we wanted to see if the warm up and cool down protocols would make sense. So what these warm up and cool down protocols are, if you sort of missed it in the video, is that they're physical exercises in routine. So they're like breathing exercises, or like you touch your toes and you sort of relax your body. This is sort of the standard thing that actors do. So the thing we sort of added to that was this extra step of strapping on a backstairs, in this case arms. You see this person, they have this sort of black belt across their chest, and sort of standing up on Baxter and sort of getting used to that motion. And then the other thing was sort of practicing these gestures. So in sync, practicing some basic gestures with the robot so that they would feel comfortable around it. And then they would understand how much space they would need, and how they would move, and sort of planning all of those details out so that when it was time for the final performance, they would feel comfortable. And the cool down was basically them coming out of this experience and sort of repeating those basic breathing exercises and routines. So one thing that we learned from sort of chatting with these actors after these multi-week sessions of working with them, this happened over 2 to 3 weeks and multiple sessions and multiple hours spent on it. What they sort of spoke about was that how this warm up with the robot that is performing practices or performing repeated actions with the robot in sync with the robot was really helpful for them to sort of build trust in it. And of course, knowing that there was a kill switch was extremely important too. And they also sort of mentioned how the idea of cooldown might also be improved. So they wanted to sort of finish the performance with the robot and sort of shut down with the robot. So they wanted the robot to cool down along with them as a way to sort of feel like that experience was complete and then sort of transition out. So there are several open questions here that we're yet to explore in terms of what kind of tools might we develop to support these kinds of routines, and how do we sort of develop these different sorts of routines for different sorts of experiences, and how would it sort of work for people who are not actors already, and how would they feel about it? So there are definitely some open questions there that we're thinking about. So I want to move to the last part of this talk, and the third question, which sort of relates to how would people use these technologies and how can they empower themselves using these technologies? So this question of why and how do people create physical digital artifacts using technologies, and how can we support them, is sort of the third question that we're asking in the lab. And I want to show you a few projects here, and they're sort of across different areas of making and creating. The first one is looking at making when you don't have all the materials that you require. So I had done a study in the past in India looking at what would be some of the challenges for students from impoverished contexts to get into, say, physical computing activities or making as a form of learning or means of self-expression. What would be some of the challenges that would come in place, and what would be some of the strategies they would take to overcome some of those challenges? So informed by that study, we sort of came up with this tool idea where we were looking at how do people continue making things if they don't have all of the materials that they need right away. And this is a pretty common scenario that most of you who might have built these kinds of projects can relate to. So sometimes you have a plan and you get very excited and you realize, oh, I actually don't have that piece of sensor, or I don't have that piece of electronics. And you then have to place an order online and you have to wait, or depending on where you are, the wait can be very long, or you probably never find that material. The other option is you can try to find a way to borrow it from a friend, but given just the situations we find ourselves, maybe these kinds of things can become tricky. And also you could try different ideas or different ways to simulate the same kind of electronics that you're missing, but it requires some expertise. So if you're a novice, you might sort of give up on that idea and maybe forget it while you're waiting for the components to arrive. So in response to that, we were thinking about how do we keep people engaged in that moment and sort of make do with what they have available and still keep playing and continuing to explore that idea for prototyping, just the basic circuits and prototyping code, so that when the materials do become available, they can sort of be substituted and that idea is still sort of alive and active and can be thought about. So the tool we created was called Polymorphic Cube, and it's using smartphone and augmented reality as a way to sort of substitute what you don't have. So you build a circuit with all the materials that you have, and whatever you don't have, you simulate using your phone. And then you can sort of program these hybrid circuits as if they were a whole physical thing and continue to sort of test out at least some of the ideas. And it's not perfect, it's a make-do system, but it still lets you prototype and do low fidelity prototyping and thinking. So let me show you an example. This one's where you want to make a lamp and say you don't have a button. So you build a circuit like you would if you had all of the materials, but for what you don't have, you connect this sort of placeholder object that we call polymorphic cube. And then you augment it using your phone to whatever you don't have, in this case, a button. And because the polymorphic cube, as you can kind of see, is just essentially some physical object on which there's a QR code and it has the electronic footprint of an LED, the Arduino recognizes all of this as a single working circuit. And so from the Arduino IDE side, you are able to program this hybrid circuit, and you're able to interact with the digital piece of material, in this case, the virtual button, and activate a real LED. In this case, you'll see it sort of turn on and off. And you can do the reverse as well. So you can have an input in the real world, and you can see it in the see the output on the screen, and we could also simulate some basic sensors and approximate their values. So some basic studies on this sort of led us to identify that most people sort of found this make-do approach for prototyping and doing low-fidelity prototyping actually quite useful. And they thought of many other places where this could be useful, say in a classroom where you don't have that much resource to buy all the materials and give one to every student. This can be one way to perhaps scale that experience, at least to get people engaged. It could be a way to sort of test your ideas while you're thinking about the electronics, but it still gives you some sense of the physicality of the experience. So you still have to think about how to build the circuit and where the components go, which is unlike, say, if you were doing it on a virtual simulator purely. So there's still some of the physicality that you can leverage and keep playing with your ideas. So there's definitely more questions here to be explored in terms of how can we make the polymorphic cube itself more interactive and perhaps even a low-cost shape-changing device, which can show you also the form factor of these devices. So there are many questions there that we're thinking about. Going on, sort of a different scale, so sort of going away from tiny electronics to making in fab labs or physical spaces and making things with big machines, say like a CNC or hand tools, which are small, but a little bit away from the electronics, and thinking about what happens when a novice goes into a maker space or a fab lab where you can build things and make things. But if you're new, you may be sort of a little bit nervous about how to use these devices or how to even go about these spaces and how to complete a project. And if you've been to a maker space, you've also probably recognized that there's usually not that many people who are able to help out. It's usually the ratio is a little bit tilted in the sense that those who need help, there are more of them as opposed to those who can offer help. So sometimes people are busy, and if you're a novice, you may also just be generally nervous, and you may tend to sort of wait or again lose interest. So the idea was, how do you keep them engaged, and how do you sort of give them an ability to sort of go through the space and make things? So we came up with MakeAware, which uses situational awareness as a basis, and it uses that framework to sort of help novices make things. And it provides cues from the environment, it provides cues from a digital assistant platform on a tablet. It helps them prepare and think about the project, and also helps them sort of think ahead, saying, if I took this step, maybe that's going to cause a certain problem, and so I should rethink my decision. So it sort of helps them in different ways and sort of helps them move forward. Of course, it's not necessarily a replacement for an actual help from an instructor, but it can be a alternative for, say, if you were only relying on YouTube videos to help you go through a space, which are not necessarily designed for that space. They're designed for the project, but they don't have all the details of the space. Or if you were simply following a tutorial, which again is not really designed for a particular space. So again, I'll show you a video.
As maker communities are growing, more novices are entering maker spaces. They may not have the knowledge to recognize objects in the environment, understand complex digital fabrication tools, or accurately predict the outcome of their actions. Situational awareness is the perception of environmental elements and events, the comprehension of their meaning, and the projection of their future status. To scaffold novices' situation awareness within a makerspace, we developed MakeAware, a digital guidance system comprised of both software and hardware features. MakeAware is designed to help novices perceive and comprehend how the environment is relevant to their project. When the maker chooses a task to complete, the state beacon at the recommended location turns blue. To help makers perceive and comprehend other makers in the space and their usage of the tools, we embed sensors in the environment and use colored lighting to indicate the status of the station. A tablet interface also conveys information to scaffold situation awareness. An overview panel helps them to project their ideas into the future by visualizing the end result and how they may achieve it. The project map shows the steps of the project as branches that need to be completed before the final step, to help makers comprehend how their tasks fit into the project and to project what future states of the project will look like by peeking at tasks. It also helps them to perceive and comprehend their possible options. Selecting a task produces the instruction panel. The minimap provides comprehension and projection support. A metadata card provides details about the task, and the image shows the intended results of the step. These features aim to support comprehension and projection by giving makers the means to form accurate expectations. A video playlist is included to support novices who lack previous knowledge. We evaluated MakeAware with 12 novice makers building a set of bookends. Overall, participants rated the situation awareness support system as being more useful than some other common methods. They also agreed that the state beacons helped them understand how the equipment was relevant to their project. They agreed strongly that the project map supported them at the highest levels of situation awareness. For more details, please see the paper.
So hopefully you got a little bit of sense of what MakeAware is. Just in the interest of time, I'm sort of going to move to one more project, and then I'll sort of summarize quickly in terms of what I'm thinking about going forward. So this is a project that's going to be part of KITE 2021. So we're very excited. And this is at a slightly different scale and looking at how do we support people to embed documentation into the objects that they make. So how do we create information-rich objects? And how do we sort of allow people to reflect on these objects where they can see the object and see information about its documentation, so elements related to its design and fabrication. So Omid came up with this platform called Documented. So I'm just going to kill the audio here so I can kind of talk a little bit over it. But the idea is that we can fabricate objects, and as part of that fabrication, we can sort of create tags, or we can create these elements that we can embed in these objects that contain bits and pieces of documentation information. And the advantage of this coupling, spatial coupling of information and a model, is that this information exists to provide some contextualization, but it also will enable people to sort of keep these documentations active and alive, therefore creating sort of more rich information objects in the world, supporting discussions and reflections and so on and so forth. So in this case, he's showing you how you can use a Tinkercad-like platform to embed different kinds of tags on a model, and then you can embed information to those tags, and you can print these tags as part of printing the model. And then you can sort of get back that information using a phone or a web-based interface. And you can take a look at the information. And if you were the creator, you will also have access to edit some of this information. So you can create a lot of different kinds of tags, and there's more information in the paper. I'm happy to discuss it a little bit later. So those are the questions and kinds of projects we're working on, and sort of going forward, I'm sort of thinking about similar kinds of things. And here's some really quick examples of what I'm thinking. So I'm really sort of interested in thinking about how can we make anywhere and with anything. So how do we make it home? How do we make, say, at a recycling plant, like you see in this rightmost image? Or how do we make at schools, but we use available materials like, I don't know, lemons and water? And or how do we make with off-the-shelf devices, say like this knitting machine, and how do we sort of retrofit it with other things? So that's one thing that I'm really interested in thinking about. The other sort of related aspect to it is how do we make many of these practices and these spaces for making more inclusive. So this is some resource that Eric Forrest, one of my students, sort of put together from his participation at Lighthouse, where woodworkers who are blind teach students who are also legally blind woodworking. And based on interactions from that workshop and member check, he sort of put together his open resource on different principles that one can sort of employ in order to create inclusive wood workshops. You're welcome to check out this link, and I'm happy to provide it later in the chat as well. And I'm sort of interested in continuing along those lines, thinking about how do we make it possible, what kind of tools to build. And sort of building on that idea of new types of tools to build for making, one thing that I'm thinking about is new forms of human-machine collaboration. And this is a project that we're sort of in preparation for writing, but the idea was, how do we sort of borrow from philosophies of technologies and looking at sort of the non-humanist perspectives that sort of position machines as having sort of agentic capacities, and how do we sort of leverage some of those concepts like composite intentionality and others, and sort of create these new forms of human-machine collaboration, which can lead to aspects like surprise in making or anticipation in making, which can lead to in turn reflection. So for example, this printer that we created called Skimpy, basically sort of you give it an input and it thinks it's very smart and basically tries to decide on the amount of, based on the density of the material, how it can create multiple copies of that same material given the input that you did. So thinking about sort of like, say you're using this for prototyping and the machine already knows that you probably need multiple copies of the same thing. So it tries to create it for you using the same material requirements that you input. Or it's aware of the environment around and it sort of uses the data as a way to print. So these are some things that we're thinking about. And lastly, I'm really interested in thinking about how we can co-design and sort of think about applications in terms of health accessories and devices. So this is some early work that Erman has started looking at building accessories for type 1 diabetes, people who have type 1 diabetes. So looking at how to build glucose monitors. So he's doing some co-designs with them to understand if modular pieces would be helpful and would people build their own devices and what are some of the challenges. And there's a lot of work to be done in this space. So that's definitely an area. So just to wrap up, I think I'm a little over 40 minutes. So I want to quickly wrap up, and it's a plug. So at University of Victoria and the Computer Science Department, there's 3 of us who do HCI, visualization, cognition. So Charles, Perrin, Miguel Nascenta, and myself. And the larger collective of us is called VIXI, and we are looking for strong students. So if you're interested or thinking about grad school or interested in undergrad research, thank you very much for the invitation. And thanks again for all of you who managed to join the call again. So it was a pleasure to be here and chat about works.